Let us solve the exercise number 8 in the part B of data structure lab. In this exercise, we are supposed to write a menu-driven program to perform operation on a binary search tree of integers. There are two things that we are supposed to perform. One is to create a binary search tree of n integers, and the second one is to traverse the binary search tree in Inorder, Preorder, and post-order traversal. So let's go ahead and let's create the binary search tree. Before we create a binary search tree, let's look at how the tree is generally created. Now we are all familiar that a binary search tree consists of number of nodes. Every node has two pointer, one pointer pointing to the left, other one will point to the right. If there are no left subtree, then the pointer will left subtree is marked as null. Similarly, if there is no subtree on the right hand side, the right hand side pointer will be marked as null. One unique property of binary search tree is all the elements on the left hand side of the root are less than the root element. Similarly, all the elements on the right hand side subtree are greater than the root element. That is true for every node. So every node, the left hand side will consist of all the elements which are less than the element, and the right hand side will consist of all the elements which are more than that. For example, if you notice over here, if I take the element n here, or the node n here, the left hand side, all the elements which are there in the left hand side, that is the left hand side subtree, they are smaller than the 4. Similarly, all the elements on the right hand side, that is all the nodes on the right hand side, or the nodes in the right hand side subtree or a right subtree, are greater than that. This is true for any node for that matter. So if I take 2, all the elements on the left hand side are smaller than 2, and all of them are greater than all the elements which are there on the right hand side are greater than 2. The other thing is, whenever we talk about a tree, we are starting the tree from the root, and we traverse across the root. So how do we start creating the structure? Now, if you look at any element for that matter, suppose if I take this one, this only this node. So there will be a root that will be pointing to the first element, or the root of the tree, so that we know that this is the starting point of the tree. And there is going to be a data element, and there is going to be a pointer that is pointing to the left hand side, and there is a pointer that is pointing to the right hand side. Initially, when we create the first node, because there is no left subtree and no right subtree, the pointer will be marked as null. So this is the general idea. So let us first build this data structure, and then we think of building the tree. So I'm going to go to the code blocks here, and I'm going to click on the new file here, and I'm going to create a new file. And I'm going to select C++ source from this dialog box. And I'll click next, and I'm going to select C as my programming language, and I'm going to click next. As usual, try to save your file at a proper location. So I'm going to go, and I will assume that this is your location, and I will search it as I'm going to save this one as a BST. Let me click on yes. So see to it that you save at the proper location, and then let me finish it off. As usual, whenever we think of writing a C program, we include the stdio.h. So I'm going to just include the stdio.h file over here. And let us try to build the data structure here. So what are the things which are there here? So this structure will consist of a left pointer that will point to one more structure of the same type. And there will be a data, and there will be one more pointer that will point to the structure of the same type. So let's build the structure. I'm going to go and I'm going to say in the C structure. You can call it with any name. I'm going to call it as a BST, that is a binary search tree. And what are the things which are there in it? So first we have a left pointer. So if you notice, we have a left pointer that will point to the similar structure. So let's build that thing. So the data type of it is again structure BST, because it is going to point, if you notice over here, every node, if you take this element, this is going to point, the left hand side will point to a similar type of structure. The right hand side will also point to a similar type of structure, which consists of two pointers and a data element. So this is going to be same thing. So it is going to be same, and it is a pointer. So I'm going to use a star here. So this is the left pointer, and because in the program they said that N integer. So the data that we are going to store is of type integer. So I will store the data as integer, and in the same way we have the left pointer, and we have the left pointer and the right pointer. So I'm not going to type that thing there. I'm going to just copy it, Control C and Control V here, and I'm going to just make it as right. So two pointers will be there. So what I have created is a structure which consists of three elements over here. The first one is a pointer that points to the left, and then we have the data here, which is just the integer number, and then we have the right pointer that's going to point to the right hand side. Now, if at all I have to create a variable of this type, I have to write like this struct BST and the variable name. This is going to be a lengthier one. I'm going to create a alias for that by using type def. So type def struct BST as a node. So what is that I have done is instead of writing this whole thing struct BST, now onwards I'm going to use only this small one letter node, which indicates the structure. So this is the other name, so like a alias name for the struct here. So otherwise whenever I create a variable, so how you write int here, one letter, whereas when we try to create a variable of type structure, we have to write too many things, so we can just reduce that part. So now first let's try to build the structure here. So what are the things that we are going to do? Suppose, let me delete all of them. So suppose if I want to build a node like this, so first I'm going to create a empty structure. Using this structure, I'm going to create an empty structure. Then, because there is a, I don't know which is the left node and which is the right node, both of them will be marked as a null. Okay, and in order to create a BST, I need to have the data. So I need to have a number. So based on that number, I'm going to create it. So for example, I create a structure which has the left is null, right is null, because there is nothing. I'm just creating one node. I don't know what is going to come on the left hand side and what is going to come on the right hand side. So I just make them as null. But I must know what is the data. So that I can't say. I will write it later. For example, if I say this data value is 6, so I have just created a structure which looks like this. So there is a data in the middle, and I have two left pointer and the right pointer pointing nowhere. Now we know very well initially when we try to create a tree, the root will be null because there is nothing in the is there in the tree. So this root itself will be grounded. But once we create one node, we can simply connect that node to the root here, so that we can say that this is the starting point. So this is the starting point. The root is going to come there. So once we create any structure, we have to connect that structure to the tree so that we can traverse that tree, or we can connect that tree. So we have to connect it to the node. That's sorry, the root. So we create a node and then we connect it to the root here. So once we create a node like this, we have to have a pointer that can be used to connect to the root there. So the return value, once we are whatever that we are going to do is, once we successfully create one node, we have to return a pointer to this element so that we can connect them to the root. So let's write a function for creating that. So this function at the end has to return a pointer to that particular structure. So it has to return a pointer so that I can connect it to the root. So I'm going to say it's going to return a pointer, and let me give it a name of this one as create tree. So create tree. When you try to create a tree, we must know, suppose say, see, for the first time you are going to create it to the root itself. For the second time, you must know whether it is to the left hand side or whether I have to connect it to the right hand side. For example, let me show it on here. Suppose if you are adding the number 1 here, so you must know whether you are going to connect this number 1 to the left hand side or right hand side. So you must know where to place that particular node, on the right hand side or the left hand side. So we need to have a pointer that is going to indicate where are we going to place it, onto the left or onto the right. So this particular method, that is a create tree, will take a pointer that I'm going to call it as a node pointer, and definitely we need a data. So without the data, as I've already told you, without this data, there is no point. Without this data, there is no point in creating the structure there or the node there, because we will not be able to place the node unless we know what is the value of that particular node. So what is the first thing? So initial, let's talk about this initial part. As I already told you, initially this will be null. So root will be null. So when the root is null, you create this structure and then you connect that thing to the root. So how do we do that? So if the pointer, so initially you know very well, this particular pointer that is being supplied to us, so this pointer is null. So if this is null, so how do I say that thing? If node pointer np is equal to null, so null. Okay. So if this is null, we are going to create the node. So how do I create the node? Let me create a temporary node. I'm going to call it as temp. How to create a temporary node? I'm going to use a malloc function. So you know very well, malloc function can be used to dynamically allocate the memory. So what is the size of the memory that we want? The size of the memory that we want is large enough to accommodate the structure. So in other words, inside the memory, inside your main memory, you are going to get an allocation that can have one left-hand tree, then one data, that is integer, and one right-hand pointer to the right-hand side. So I need a space inside my memory to accommodate this. So I'm going to say size of this memory allocation must be equal to the size of this particular tree. Now the malloc will return a void pointer, and I want a pointer, so the right hand side will be a void pointer and the left hand side will be a node pointer, so there will be a mismatch. How to handle that mismatch is, I'm going to typecast that, and I'm going to say that whatever the pointer that is returned by it is converted into a pointer of type node, that is typecasted into a pointer of node or node pointer, and then it is returned to the temp, so that both the right hand side and the left hand side will match. And when you are creating a structure, so initially you are going to place the value here, so you know the value, so that is the data. So I am supplied this particular function. If you notice over here, the data is supplied to us. So let's fill the pointer. So I'm going to say temp is my pointer, and the data inside that will be the data that is supplied. So whatever the data that is supplied to us will be stored inside this structure. So this structure, whatever we have created, so the data whatever is there, so that data will be stored here. And initially we don't know which is the left, where the left subtree is pointing and where the right subtree is pointing. So we are going to initialize both of them as null. So this will be null and the right hand side will be also null. So I'm going to say temp dot left hand side will be null. You can combine this into single thing. So I will, for the brevity of explanation, I'm just doing it. So right hand side is also null. So just make, because I'm just explaining, you can actually combine this and you can say that, I will just show you what you can say is left hand side is equal to right hand side is equal to null. So this is null as well as this is null. It will be done in one shot, but for my explanation purpose, I'm going to make it a slightly larger. So left hand side is null, right hand side is null. So this is what I have done. So I have placed the data and left hand side is null, right hand side is null. Now this has to be, this node has to be connected. So this has to be connected. That means I have to return that thing. So I'm going to return this temporary node, whatever I have connected, to the calling module so that it can be returned out. So this node will be returned back to the caller so that it can be placed, it can be connected to the root. Now what if I'm creating the second node? Now if I create the second node, where should I keep it? So should I keep it on the right hand side? Should I keep it on the left hand side? Where is that I'm supposed to keep it? So it depends on the value of the data which is there over inside this node. If the value of this node, this data, in other words, if the value of the data is smaller than the data which is there in the parent node, then this will go to the left hand side. So I have already told you all the subtrees on the left hand side is smaller than the existing one. I'm going to just use this one. So this let me call it as 4. Okay, so that is I'm not using that because it is transparent, so it comes in middle. Okay, not that I am not interested in, but it will come, it will not hide that null there. So if it is 4, then you have to go to the left hand side. Suppose if you are creating one more node, and let's say that node is 2, then what you do, you start from the root, you check what is the value of this 2, this is the new node, is it smaller than the root? If it is smaller, go to the left hand side, again come to the next node and check whether this is smaller than the data. Yes, if it is smaller, if this is smaller than this, go again to the left. Now when you go again to the left, you find that the pointer is null. If the pointer is null, you just connect them here. Okay. Suppose if you are making it as 3, in that case, what's going to happen? You notice that when you start from the root, at the root, this 3 is smaller than 6. So you go to the left hand side. But when you go to the left hand side, what you notice is this 3 is still smaller than 4. So again, you go to the left hand side of this thing. Now, when you compare this 3 with this one now, so this data with this one, you find that it is larger than 3. So you go to the right hand side. Now, when you go to the right hand side, if you find that this pointer is null, it is not pointing anywhere, then go to this and connect this new node over here. So that means if the pointer is not null, you compare the value of the parent with the new element. If it is smaller, go to the left hand side. If it is, for example, if let's say, if this is 9, if the value is greater than this one, if this data is greater than the parent, then go to the right hand side. So let's do that one. So if it is smaller, you go to the left hand side. If it is larger, you go to the right hand side. How do I write that thing? So I'm going to check here. If the data that is passed to me, this data, if this data let me remove this thing. If this data is smaller than, okay, node pointer dash data, that means if this is what is the meaning of this is if this value, let's say this is say 5, okay, if this is if this new data that is being supplied to me, if it is smaller than the pointer, suppose you are starting from the root, if it is smaller than this one, go to the left hand side. So that is the meaning, go to the left and then try to create the tree. So you are supposed to create the tree on the left hand side. Whether you are going to create it here, whether you are going to create it here or somewhere else, that is different thing. You have to go to the left hand side. So left hand, so this particular node will be connected to somewhere in the left hand side of this particular tree. So you have to go to the left hand side. So if it is a smaller than, let me write that thing, if it is smaller than that, then you have to create a tree which is there on the left hand side, okay, and then pass the data. You not the same data has to be passed. You have not just created this tree, you still don't know, remember, whether you have to create it here or anything. You need this data so that you can compare it with the other, okay. Then and then remember, you have to create it on the left hand side and then somehow connect somewhere to the left hand side. So you have to connect it, in other words, you have to connect to the left hand side. So how can I say np to the left is equal to that. So you, in other words, you create a node, and then connect to the left hand side of the tree. So you connect to the left hand side. So this is the left hand, in other words, this is the left pointer. You connect to the, or in other words, you give it to the left pointer of that particular node. So this is what you have done. Otherwise, else, if it is greater, so if data, the given data is greater than node pointer data, okay, then it is the same story. You create on the right hand side. So you create the tree on the right hand side. So I'm going to say right hand side and then pass the data, because you really don't know. So if the value that you are trying to create, if it is, let's say this is 51, so then you don't go to the left side, go to the right side, somewhere in within the tree, somewhere right hand side, it's going to connect. So in other words, it's going to connect to the right hand side. So it's going to connect to the right hand side of this tree. I don't know where it is going to come, because we have to find out the exact place. So there may be other nodes here, so you have to connect to the right hand side, somewhere on the other side you have to connect it. So this is what is the idea. So if it is that you have to connect it, remember, finally once you create this node, you have to pass it back so that you can connect it to this part here. So you have to pass it back so that you can connect it. So finally I'm going to say whether it is a left or right. Finally I'm going to return the node pointer. So this pointer, whether it is left, right, or whatever it is, you have created, you pass this back so that it can be connected to the, whether it is left hand side or right hand side, you just pass that thing back to the somewhere, either here or anything. You pass it back so that it can be connected. Otherwise, it will be a dangling node without anything. You have created, everything is successful, but it is not connected to the tree. So in order to connect it to the tree, just pass it back to the caller, and in other words, you just give it back to the node saying that, okay, this is the tree I connected, you now this is connected over here, and that. So this is for the creation of the tree. Let us now understand how do we parse the tree. So we can traverse the tree in three different way. One is in order, pre-order, and post-order. What is in order? In order is a very simple technique. What is in order traversal? You come to the root, first go to the left side, complete the left side, come back to the node here, data here, and then go to the right hand side. So that is the idea. First go to the left side, so traverse left side, and then come back to the root and then go to the right hand side. So same thing from here, go to the left hand side, come back to the root and then go to the right hand side. So same idea, we are going to use it. So let me write the in order. Remember, we are when we say we are traversing, in this case we are just going to print the value, so I will not return anything back. So this particular function will not return anything back, so it is going to be a void function. So I'm going to say in order, and we need the starting point. So let me say this is the starting pointer node. Okay, I'm going to just call np. Okay, so one node, because either it will be root or it will be some pointer starting from somewhere. So some node pointer either from the root or from some node pointer, you will be doing a traversal. So this I'm going to just call it. Now the first thing is, suppose if you reach here, if you reach to this point. So from here, so let's start from here. You start from the root. First go to the left. So this is left. Then go to the left. Okay. Now again, if you go to the left, this is null here. There is no more left. When there is null here, don't do anything. Just come back. Okay. Similarly, when it is null, there is nothing to traverse here. So this is like the road is closed. Come back. Okay. So when you enter, it's like you get the null, means the road is closed. You cannot get you can't go any further. Just come back. So the first thing that we are going to check is here, if our road is null, that means if the pointer is null. Okay. So when we reach here, if you notice here, when we reach here, the pointer is null, nothing to be done, just come back. So how do we say that? Just return back. So I'm going to say just return. If it is null, just return. Otherwise, do the thing. If it is not null, what is the technique? First go in order to the left, then come back to the root, then go to the right subtree. So let us go. Otherwise, traverse the in order traversal to the left side. So how do you say? Go to the left side. Okay. Node pointer dot left. Why did it said anything? Okay, left. Then print the value. Remember, we see it is like you go to the left side. You go to the left side. Okay, left side, and then come back to the center. That is the data, and then go to the right hand side. When you say come back to the data, we are going to just print the data. So I'm going to say %d and then a space. Then I'm going to say np, and then it is not showing me the pointer. So sorry, it's not showing me because I have not typed as a node. I have to type it in a capital node. So now it is going to show me. So that is why it is not helping me with the, when I put this one. So this is, it was not coming because it could not recognize that node. So come to the print the data, and then again do the traversal. I've just selected that, Control C to copy it, Control V to paste it, and I'm going to go to the right. Okay. So where is the right part? Okay, right. Let me just format it. So in other words, you start from the root, you go to the left subtree. So you go to the left subtree, then print the data here. Okay, then go to the right subtree and then traverse it in the same order. Okay, so that is what you are doing. What about what is the next is a pre-order. What is a pre-order? Pre means first visit the node, first print the value, then go to the left, then go to the right. So first print, then go left, then right. So pre-order traversal. I'm not going to type this whole thing again. I'm going to use a Control C to copy it and Control V to paste it. I'm going to call this one as a pre-order. So if it is null, if the root is null, there is nothing to be done. Otherwise, go to the pre-order, first print the value. So I'm going to select it, Control X to cut and Control V to paste it. Then print, traverse it in the pre-order traversal of the left subtree and pre-order traversal of a right subtree. Done. In the same way, let us do the next one, that is post order. What is the post order? You print the data at the end. First traverse. So what is the post order traversal? First go to the left, then go to the right, and finally, so go to the left, go to the right, and then finally come and print the value. So that is it. So go to the left, go to the right, and print the value. As usual, if the node is null, if the pointer is null, that means you have reached the end of the tree. That means you have reached there is nothing much, so you just come back. In any case, if you reach the null, nothing to be done, you just have to come back. So this is what you have done. So we know how to create a tree. We know how to traverse it in the pre-order, in order, and this is not pre. This one was what was it? Post order. So sorry, this is post order. It is not a pre. This is post order, and this one is also post order. Post means you know very well afterwards. Pre means before. Okay. So we know how to traverse in the in order, we know how to traverse in the pre-order, and we know how to traverse in the post order. Post means what is the meaning of saying post is first go left, then go right, and then finally print the value. So first go left, then go right, then finally print the value. Now let's write the main function here. I'm going just to make some place here. So I'm going to write the main void main. I'm going to write this main function here. What are the things that I need in the main? Definitely I need a root here. So I'm going to start a pointer called as a root. Let me initialize it with the null. Okay. And then I need some integer values because they said that there are n integer values. So you must know what is the value of n. So I'm going to put n. Now, in order to input the n value, so you need to definitely, we are going to use a for loop. And you know very well, a for loop has a looping variable, and generally we take that looping variable as I for the for loop. So I'm going to use that thing. Definitely, whenever you want to create a node, in order to create a node, you must know what is the value of the data. So you must know what is the value of data. So I'm going to use the data. And I need one more thing. There are two things so that we are supposed to do it. Either we can create it or we can traverse it. So two choice. Choice number one is to create. Choice number two is to traverse. Definitely choice number three is to exit. So we are going to ask the user, because it is a menu driven program, we are going to ask the user what are your choices. So I'm going to use one more variable called ch to get the choice of the user. I'm going to use the do while loop. So do while the choice is not equal to 3, because I told you if the choice is 3, I'm going to exit. If the choice is 1, I'm going to create the tree. Otherwise, if the choice is 2, I'm going to traverse the tree. If the choice is 3, I'm going to exit the thing. Let us show the menu. They said that it is a menu driven program. So let's create a menu here. I'm going to use the printf here. So printf, and I'm going to use a /n. Choice number one. Choice number one is to create the binary search tree. Okay. Choice number two is to traverse the tree. Okay, /n. Choice number three is to exit the one. Okay, then I'm going to use a /n, and I'm going to use a dash 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 dash. Okay, and /n again, and I'm going to say your choice. After that, I'm going to put a colon and a space. You notice I put extra space here, so some extra space here so that it looks nicer. And I'm going to ask the user scanf, and I'm going to ask the get the number that is typed by the user, and I'm going to store it in the ch. you know very well. CH is the choice that I'm asking. If the choice is not 3, I will do something. If the choice is 3, definitely I'm going to exit it. I'm going to just save it, and I'm going to just run my program by clicking here, that is compile and run. So I get a error here. Now see, sometime when you run it, you get this is the problem. You notice that it is showing you an error, but you don't know what is wrong. So how do I know that what is wrong? So if you want to know what is wrong, you just go to this view and you have an option called the logs. So shortcut is you have to click here, and it's going to tell you that you have missed a semicolon there. Okay, so I'm going to just put a semicolon here, and then I'm going to run it. You can close it whenever it is not required, and if you want, you can again press F2 to get it back. Okay, let me run it now, and this is how it's going to look like. So you have the first choice is to create, the choice 1 is to create, choice 2 is to traverse, choice 3 is to exit, then you have dash 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 and your choice. Okay, here you have to type the choice. If you type any choice, now choice 1 I have not completed, so it's going to come back. Choice 2, it's going to come back. Choice 3 is going to exit the program. Okay, so let's complete the program now. So I'm going to use the switch case for handling the choices. So let's handle the case number 1. So case number 1 is we are supposed to create a tree. In order to create a tree, we must know what is the value of n. So let me ask the user. So I'm going to use the printf, and I'm going to say /n, and then I will say enter the value of n. Put a space here. It is better you put one space there. And then I'm going to use the scanf and the %d to read the value of n. For your kind information, I have taken n in capitals, so I am going to use the n in capital only. Once I get the value of n, I need to, so if the person says n is 5, what is the meaning of n is 5? You are going to create a tree with 5 nodes. This is one node, 2, 3, 4, 5. Okay, 5 nodes, 6, 7, and so on. So how many numbers of nodes are there? So enter the value of n. Then I'm going to say print f. So it is not enough if you say there are 5 nodes are there. You have to say what is the value of this node, what is the value of this, what is the value of this, what is the value. So now I'm asking what is the value of. So I'm going to say /n, enter %d, that is n, whatever n is there, the data values into BST. Okay, so I'm going to use that, and this is the en here. Then I'm going to use the for loop for reading that value. So I'm going to say I is equal to 0, I less than n, I plus plus. So that is it. And I'm going to use a scanf function to read the value of this one, %d, %d, and data. So the minute I read the data, ampersand was there. So ampersand data. Once I read the data, I will have to create, it is not enough if I just read the data. I'm going to select this one and just drag it up. Okay. Once you get the data, once you know what is the data, once you know what is the data, you have it, then create the node. You know, once the data is there, create the node. How do you create the node? You have the already created a function, create a tree, and the starting point is root, and then whatever the data that was. The only thing that I'm going to make a small change here is, even though I've initialized it, a root with the null, I will reinitialize the root again with the null. I will tell you what will happen if I don't forget. If you don't do it, don't do this one, you will get some one strange behavior. Okay? If I don't forget, because as I talk, sometimes I just forget. You will find a strange behavior if you don't initialize it. and as you run the program, you will find you're going to get it. Okay, so let's go ahead and let's try to create this one. So with this, I have created my tree. So this is how it's going to look like. Now I'm not traversing. Where is the? This was supposed to be semicolon. So this is how it's going to look like. Suppose if you say create a node, and there are two elements are there in the node. The first element is 10. The second element is 20. You press enter, and now no traversing, because this is what it's going to come. You notice that it is coming very close. I should have given one space here, one colon and space here, so that it looks great. Let me rerun it here one more time. I've added extra space there, otherwise they will touch each other. Okay, so 2 and then 10, 20. So what is this one? Enter the total values. So total values I have typed 2. Enter the total values. Yeah, value of n I have typed it as 2. Then I am supposed to type two values. So enter two data values, 10 and 20. So you are going to create a tree. First one will be 10, and the second one, because it is a BST, second one will be 20. So you are going to create a tree like this. Okay, and so on. Let's not let's exit it. Let's try to traverse this one. I pressed 3 here for exiting. Let's go for the second case. What is the second case? So the second case is case number 2 is traversing. So case number 2, if you notice, traverse. So let's traverse the tree here. So we will first do it in order. You can do it in any way you want it. So I'm going to say slash n, and I'm going to say in order, in order, in order, traversal, traversal, and I will put a colon and that. Okay. Then I'm going to call the method in order traversal, and I'm going to supply the root to this one. Done. In the same way, I will go with the post order and pre-order. So the next one is pre-order. I've just copy pasted it, Control C to copy and Control V to paste. This is pre-order. Then this one is also pre-order. Done. Similarly, I'm going to paste it one more time. Paste it here. This is post order. So I'm going to say post order, and I will call it as a post order traversal. So this is one. Then I'm going to break the case here. Case number 3 is a very easiest one. So you are exiting. So I'm going to just use a printf statement saying that we are exiting this one. So I'm going to say exiting dash 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 and maybe one more dash and slash en. Suppose if somebody types apart from this, if somebody types some strange number, then I'm going to use the default, and let me put a break here before I put this default, put a break here. And then if suppose somebody types something else, I'm going to use the printf, and I'm going to say slash n wrong choice, wrong choice. Okay, and maybe slash n. Done. If you want, you put the break. The break is not really required because it's the last thing in the switch statement. I will remove all the extra lines that I've added. So this is required. This is the main that is closing. So I just removed everything. So this is your program. Let me save it, and let's run it. Let's see what is going to happen. So I'm going to create a node here and press enter, and there will be only one element, and I'm going to type 10 here. So what is the meaning of this is you have a node here with the 10 only. Left hand side is null, and right hand side is also null. In whichever traversal you do it, because there is going to be only one element, all of them will print the same element. So let's press enter, and let me try to traverse it. And you notice that when I try to traverse, it is not printing anything. Okay, what is the problem. Let us see what is the problem. So let me go back to my print f node pointer data. So I'm not printing anything. By the way, let's when I created this node, did I type this data? So that the data is there inside here. And now what I notice is it is not pointing. So, oh, by the way, sorry, there is a huge mistake in my program. Sorry about that. See, I created this tree. So this whole tree is created. So the strange problem here is there's a whole tree is created, but I have not connected this tree to the root. You see the what a grave mistake I have done. So here, sorry, as I talk sometime, I just tend to forget things. This is the root. I have to connect it to the root. Otherwise, what will happen is you just keep on creating it, and you don't connect it to the root. Means every time you are starting from the root is null altogether. So you just comes to the null and says there is nothing is there. Sorry about that. Okay, so let's go ahead and let me try one more time with the saving and run it. Okay. So quickly I'm going to say my choice is 1. There is going to be only one element and the value is 10. I'm going to traverse it and all of them will be 10. Okay, now I'm going to create one more time. So I will again type create the node. If you want, you just put 1/n here. So let me exit it and I'm going to just put 1/ here. These are just the things that otherwise it won't look nice. Okay, so just exit it. Just after this, let me put one print f and 1/n. So this is just to make the things look great. Otherwise, it is touching. Okay, the menu is touching here, so that it is won't look nice. Let me run it one more time. Without that, also there is nothing wrong in the program. So let me create this tree, and there are two elements are there. The first element is 10. Second element is 5. So what is this one? You have one element 10 here. Second element is here you have second element is 5. The two elements are there. So let us try to traverse this one. Let me press enter and let me traverse it. So how is it going to come? Let's first verify the answer. So I'm going to go over here and I'm going to I have three elements over here. First one happens to be 10 here and the second one happens to be 5 here. We're done. So you start from the root. So in order is first go to the left and print the value. Left 5 is printed. Then come back and print the root. Then come back and print the root. What about the pre-order? Pre-order, you first print the value. You first print the value 10. Then go to the left. Right hand side, there is nothing is there. So you don't have anything. So it's going to be. What is in order? In order is post order. Post order is you go to the left. You go to the left. So you print it. You go to the right. There is nothing is there in the right. Come back and print this one. Okay. Let's go to the. Let's try one more time. I'm going to create the tree again with again two nodes. This time, first is 10. Second one is 20. Okay, let's traverse it and just see what is the answer. So what is this I have created? So I have created the 10 here. Now remember this is 10. Second one is this one 20. What about the left hand side? Left hand side is null. There is nothing is there. Second one it is 20. So what is the in order here? So in order is go to the left, nothing is there in the left, come back to the root, print the root, go to the right, print the right element. What about pre-order? Pre-order is first print the value, print the value, go to the left, there is nothing is there in the left, go to the right, you have some value, that is done. What about the in order? Sorry, post order. See, post order, go to the left, nothing is there. Go to the right, print the value. and come back and print the root. Done. Let me now create one more tree here. So last one to create with the 3 elements. So I'm going to say first one is 10, second one is 5, third one is 20. Press enter. Let's traverse this one and let's see how is it going to create. So I'm going to create the tree now. So let's look at this tree. So this is first one is 10. Okay. Second one is second element. So you have the second element is 5. So less than 10 is going to be 5. So this is going to be 5. And second, next one is third, which is greater than 10. So this is going to be 10 here. So this is going to be 10 here. So done, 10 here. So let's start with the in-order traversal. So in the in-order traversal, first go to the left side. So you go to the left side and print the value. Okay. Come back to the root. You come to the root and print the value. Go to the right and print. Sorry, this is 20. Sorry, this is 20. So this is 10, 5, 10, and 20. Then print of this. Now let's look at the pre-order. In the pre-order, you first print the root. You first print the root. Then go to the left. Then go to the left. Then go to the right. Then go to the right. So this is the pre-order. Now let's go to the next one, post order. Post order, you first go to the left. So first go to the left. You first go to the left. Then to the right. Then to the right. And then come back to the root and print it. Now, before I close it, I'm going to just tell you, I told you that I made this one as root is null. Okay. What will happen if you remove this root equal to null? Okay. Your program won't crash, don't worry. Okay. So let me save it and then run it. Okay. You create a tree. So you create a tree and there is one element in the tree. Just type 10. Okay. You traverse it. I'm not going to tell you what is going to travel. You create the tree again. Remember, now I'm not initializing. The tree is already there. That one tree was already there. So root, say what is this? Escape. Okay, then try one more time. That root was there. See, the root is not now made null here. So I removed that root equal to null. That means the tree is already there. The root is not null. Now suppose if I create one more node here. Okay. So my choice is to create the tree. And again, if I add, remember I have added one node 10, which is already there. Now I have not made, I removed that null statement. So I'm going to add 20 here. So what will happen? If I traverse, no, remember, so I'm creating the tree. I said create a tree. Now I've created a tree with the, again 20 as the element. First time I created a tree with the one node and 10 as the element. So there was only one node was there. So only one node was there with the 10. Second time I am creating with the one node with the 20. You expect that there is only one node, left hand side is not there, right hand side is not there. Is it not? But you see what is going to happen. When a traverse, you notice that it is actually adding to the existing tree. The reason is you have not made that as null. When you make the tree, when the root is not null, it will keep on adding to the same root and you get a wrong answer. I'm not saying wrong answer, but you get unexpected answer. So it is better you have this statement here. Okay, root equal to null. It is not wrong, but in that case, you must be extremely careful that whenever you are adding it, you are adding to the same tree. You are not recreating it or you are not creating a new tree there. Okay, that's all in this video. We will meet again in the next video. Thank you for your interest.